Hello there. Today I'm going to go through AQA A-Level Maths Paper 1 from the June/November 2020 series. So let's get straight into it. The first question is the binomial expansion, and we're asked that 9 plus 2x to the power of a half is given by these first three terms, and part A asks, where is this expansion valid? Well, this expansion is valid in the case where the second term is less than the size of the second term is less than the size of the first term. So in other words, if we divide by 2, we have that the modulus of x is less than 9/2. So it's the fourth option there. And then part B, find the value of a. Well, then we have to do the expansion, so a bit more work here. So first of all, divide by the 9. We'll take 9 out as a factor, I should say. So we get 9 to the power of a half outside, and then we have to divide the bracket by 9. So we get 1 plus 2/9x to the power of a half. 9 to the power of a half is just 3, so we'll sort that out in front. And then the rest of it is 1 plus a half 2x/9 plus, so this is n minus 1 over 2 factorial, and then x squared, so it's 2/9x squared, and so on. You didn't really need to do all the rest of it because you were only interested in the first term. So we got 3 times 1, which is 3. So A is 3. Question 2. We're searching for a solution to an equation, and we see a change of sign, and the conclusion might be that there's a root between them. Now, there's something else that's important if there's a change of sign. That's that the function is continuous between those two values, so between -1 and 1. And for 3 of these functions, that's fine. So x and x cubed, that's just like that, and x cubed is just like that. So that's continuous from -1 to 1. The other one is also continuous because it has an asymptote at x equals -2, but that's not between -1 and 1, so that's not a problem. 1/x, though, we have a problem at 0. X equals 0 is not part of the domain, so therefore that would be incorrect to conclude that there's a root in there. Okay, next one is about a sector, and we're given information about the perimeter of the sector is 6, and we on the diagram we have that the angle subtended is theta and the radius is 2. So let's write down an equation for the perimeter. So the distance around the shape, well, it's going to be twice the radius, okay, so this side and this side, and then plus the arc length, and the arc length is given by r theta. So let's put in the values that we know. So 6 for the perimeter, the radius is 2, so that becomes 4 plus 2 theta. And if you solve that, you get theta equal to 1. Okay, modulus next. So part A asks us to sketch the graph of this function. So how do we go about doing that? Well, first of all, the modulus. What is the modulus? The definition of the modulus, it's a piecewise function, and it's defined like this, that it's equal to x if x is greater than or equal to 0, and it's equal to minus x if x is less than 0. So what that means is whatever's in the bracket stays as it is if the bracket is greater than or equal to 0, and we put a minus sign in front of it if the value of the bracket is less than 0. So what we can say is that if 2x minus 6 is greater than or equal to 0, which if we solve that, that's the same as x greater than or equal to 3, then in that case, y is equal just to 4 minus 2x minus 6. So we don't change anything. We just remove the modulus bars and put the brackets in its place. And if you solve that, we've got 4 minus minus 6, which is 10, so 10 minus 2x. So we'll come back and draw that in a moment. In the other case, where the argument of the modulus is less than 0, which means that x is less than 3, then the definition of the modulus is that we put a minus sign in front. So we're going to get minus minus, so that's plus 2x minus 6. And if we simplify that, we just get 2x minus 2. So let's plot these on here. So the first one, y equals 10 minus 2x, it would cross the y-axis at 10, and it would cross the x-axis if we put y equals 0. We get x equals 5. So that would look like this. I'm just doing it as a dashed line for now, and you'll see why. So that's 5 there, and this would be 10. The other line, y equals 2x minus 2, well, that would cross the y-axis at minus 2, down here somewhere. And it has a positive gradient of 2. And this would, if we put y equals 0 in, this would cross at x equals 1. So let's say there. And the gradient of one should be the negative of the other, so it should be symmetric. And where these points cross, this must be where x is equal to 3. If you substitute x equals 3 into the formula, you get y equals 4 minus, well, in both cases minus 0 then, because it's the same point. So we just get y equals 4. So this is 3 and 4. X equals 3, y equals 4. This point here, we should label that as well. This was x equals 1. So the graph that we want is when x is less than 3, it's that increasing line, and when x is greater than or equal to 3, it's this decreasing line. So it's that part that we want. For B, solve the inequality. So we're going to do the same sort of things that we've just done there, split it up into two calculations. So you either get 4 minus 2x minus 6 is greater than 2, which is the same as writing 10 minus 2x greater than 2, or minus 2x greater than 8, and if we, minus 8, and if we divide by minus 2, we have to change the sign of the inequality. Okay, if we divide or multiply by a negative number, that's something that we just have to remember to do. So minus 8 divided by minus 2 is 4, so that gives us x less than 4. The other one is if we do minus minus, so we get plus greater than 2. So here we've got, if we move everything across apart from the 2x, we're going to get 2x is greater than 4. And so x is greater than 2. This is a compound inequality, so we can combine these together. So we can say overall that x must be greater than 2, but also less than 4. Another way, if you want to write it using set notation, you could write that as it must be between 2 and 4, and using round brackets to represent strictly less than or strictly greater than. Okay, so various ways to write your final answer there. Okay, what's next? Oh, proof next. Prove that for integer values of n, such that 0 is less than or equal to n and less than 4, that this inequality is true. Because it's just integer values, and because we've only got from 0 to 3, because n is less than 4, so n must be 0, 1, 2, or 3. We can just do this one by exhaustion. So we can just try all the possible values. So if we have 0, we're going to get 2 squared, which is 4, is greater than 3 to the power of 0, which is 1. So that's n equals 0. N equals 1, so we get 2 cubed, which is 8, is greater than 3 to the power of 1, which is 3. Yeah, that's great. That's true. 8 is greater than 3. Yeah. What about when n is 2? So we'd have 2 to the power of 4, which is 16, is greater than 3 squared, which is 9. Yeah, that's true. And if n equals 3, then we've got 2 to the power of 3 plus 2, which is 5, which is 32. And that's greater than 3 cubed, which is 27. So yeah, we've shown it for all those values. That's all we need to do. Okay, this next one, somebody's done an indefinite integral of 1 over x, and 4 different answers here, and we've got to say what's wrong with a couple of them. So first one, Tom's answer here, he's written integral 1 over x is equal to ln x. What's wrong with that? Well, he's missed the plus c. I'm sure all your math teachers have shouted that at you many times in the past. What's wrong with Josh's answer? Well, it shouldn't have a k in there. Okay, k is unnecessary. Okay, or you could just say that k should be equal to 1. There's no point in writing k. That's the problem there. And then the last one, explain why Floella and Georgia's answers are equivalent. Well, if they were equivalent, then let's have a look. So Floella has written ln of a times x, and we know from rules of logarithms that we can write that as log x plus log a. And Georgia has written that her answer is log x plus c. So they are equivalent if c is equal to log a. Okay, so that's the answer there. Done. And on to the next one. What have we got next? We've got sequence, and we're told that the n plus 1th term in a sequence is equal to 3 minus the nth term squared. We're told that the first term is 2. Find u3. So we just work them out one at a time. So u2, first of all, is going to be 3 minus u1 squared. So 3 minus 2 squared. 3 minus 4 is minus 1. And then u3 is going to be 3 minus 1 squared. Minus 1 all squared is 1. 3 minus 1 is 2. And what you'll notice here, which is useful for the next question, is we started with 2 for the first one. We've got minus 1. We've got 2 again. So if we worked out u4, we'd get minus 1 again. And it would just keep alternating. So if we want to find u50 for the next question now, just notice that if n is odd, then un is always 2, and if it's even, then it's always going to be equal to minus 1. It's just going to alternate between those two values. So therefore u50, 50 is an even number, so that must be equal to minus 1. And the last part, state a different value for u1 which would give the same value for u50. Well, if we go back to the start, we had u1 equals 2. So the function is we take 3 minus the previous term squared. So if it wasn't 2, but it was some other value, what other value squared would give the same value as 2 squared? And the answer there is if I had u1 is equal to minus 2, because we know when we square a negative number, we get the same answer. So it doesn't matter if we've got a minus 2 there. So that's the alternative, is that u1 is minus 2 instead. Okay, I struggled to squeeze this one onto the screen, but let's have a look. So we're told that some astronomer is looking at the number of hours of darkness throughout the year, starting from January the 1st. So t is the number of days along the x-axis, h on the vertical axis, the number of hours of darkness, and obviously as we go towards the summer months that drops and then it increases again. It follows this transformed sine function. So the number of hours is equal to some constant times sine, some function of t, and then plus 11.7. And we're asked to do some calculations with that. So first of all, 8a, find the minimum number of hours of darkness predicted by Mike's model. Give your answer to the nearest minute. Okay, Well, this one's fairly straightforward. The minimum is going to be when the sine part has its minimum. Okay, so when sine is equal to -1. So in that case, h is going to be equal to minus 3.87. So remember, sine goes from -1 to 1. So we've got minus 3.87 plus 11.7, which is 7.83. It says to the nearest minute, so we can't just leave it as 7.83 hours. So what is 0.83 of an hour? Well, 0.83 times 60 minutes is approximately 50 to the nearest minute. So in other words, h is 7 hours and 50 minutes. Part B, find the maximum number of consecutive days where the number of hours of darkness predicted by the model exceeds 14. Okay, so over the long term, it's going to do this. Okay, so it's going to go down, up, and so on. So there's going to be, if there's a point here which is 14 days, there's going to be, if we start counting here, and we're trying to count how many days have more than 14 hours of darkness, then we need to go to over the top of that peak to the next point where it's equal to that. So what we need to do is we just need to find two consecutive values of t and find the difference between them. Okay, so we just have to solve the equation for t, but the equation is that h is greater than 14. So we need to solve the equation 3.87 sine, I'm not going to write the whole bracket out, plus 11.7 equals 14. So if you rearrange that, move the 11.7 to the other side, so that's 2.3. Now divide by 3.87. So sine of the bracket is going to be equal to that. And if you solve that, you get, so inverse sine of that is about 0.6364. And we also know when we're solving sine functions that there must be a secondary solution, which is pi minus that. Okay, so if you then solve the rest of the bracket, so multiply by 365, divide by 2 pi, minus 101.75, then you can get, for example, these two values of t, minus 64.78 and 43.78 from those two values. And so that we just need to find the time between those. Let's do it up here. So 43.78 minus the first value, and that's approximately equal to, well, it's 108.6. So how many, the maximum number of days must be 108 then. Okay, because we haven't reached 109 full days. Right. Part C, Mike has a friend Sophia who lives in Spain who's also recording it, and she gets some different data because she's closer to the equator. And she tries to use Mike's model but decides to increase the 3.87 value. So the question is that 3.87, which was in front of the sine bit, what does that do? Well, this in front of sine, this includes this controls the amplitude of the wave compared to some equilibrium value. Okay, so this value here is the 3.87 bit from the peak to the average value. Now her data shows less variation than Mike's. There's a smaller range, so it's not appropriate. Okay, if you increase 3.87, that would increase the range. Okay, but her data shows the opposite. It shows that it's actually got a smaller range than Mike's data. Okay, so it's not appropriate. Right, question 9. Oh, I've cut the top of the question off. Sorry about that. So Chloe is attempting to write 2x squared plus x over x plus 1 times x plus 2 squared as partial fractions. And this is her attempt. So she's done something wrong. And A part 1 says use a counterexample to show that that can't be correct. Well, just put a value of x in the left hand side, and the easiest thing to do is just to put x equals 0 in. Okay, because that if you look at the numerator on the left hand side, that would be 0, so the left hand side would be 0, and the right hand side would be equal to 1 over 1 minus 6 over 2 squared, so 6 over 4. So 1 minus 3 over 2, so that's minus a half. And 0 is not equal to minus a half. Okay, so that's all that needs to be said there. Explain her mistake in step 1. Well, she should have an extra term in there. Whenever you've got a repeated factor like this, then you need to have an extra factor in there, which is x plus 2. Okay, so whatever the power is, you need terms of increasing powers in the denominator up to that power. So that's what she's missed out there. So 9b then is, well, basically the question is, do it right. So how do we actually work this out with partial fractions? Okay, so if we had the full thing, we had this was equal to a over x plus 1 plus b over x plus 2 squared, and then the term that she missed, c over x plus 2. Usually you would write these in the opposite order, I suppose, but we'll just go like this. And if you might have been taught the cover up technique, where you cover up what's already in the denominators and see what's left, or if you just cross multiply the denominator from the left hand side, then you get 2x squared plus x is equal to a times x plus 2 squared plus b times x plus 1 plus c times x plus 1 x plus 2. And we just need to find the values of a, b and c now. And the easiest way to do that is to choose appropriate values. So if, for example, we pick x is equal to minus 1 first of all, the left hand side becomes 2 times 1 minus 1, so that's just 1. And the first term here becomes minus 1 plus 2 is 1, so we just get a, and the other two terms disappear. So we immediately get a is equal to 1. If we put x is equal to minus 2, that will eliminate the first and third terms on the right hand side. And we'll get, so on the left hand side, 2 times 4 is 8, minus 2 is 6. And only the middle term remains on the right hand side. Minus 2 plus 1 is minus 1, so minus b. So therefore b is equal to minus 6. And then for the third value, we can pick any other value we want. So 0 seems like a sensible thing, because it's probably going to give us the least calculation to do. So the left hand side will be 0, and the right hand side will be 2 squared times a, so 4a, 1 times b, and then 1 times 2 times c, so plus 2c. So 2c is going to be equal to minus 4a minus b. So that's minus 4 plus 6, which is 2. So if 2c is 2, then c is 1. Okay, so if we want to go back to the original, just put those values in now. So we've got 1 over x plus 1 minus 6 over x plus 2 squared plus 1 over x plus 2. Okay, and that's it done. Okay, arithmetic series now. So this is sigma notation, which you're hopefully familiar with. And what this means is that we substitute the values in from 5 up to 20 and we add the terms together. So it'll be 4 times 5 plus 1 plus 4 times 6 plus 1 plus 4 times 7 plus 1 all the way up to 20. That's what the notation means. So what's the first term in the series? Well, it's just where we substitute in r equals 5. So we've got a, that's the usual symbol that we use for the first term of a series, is going to be equal to 4 times 5 plus 1. 21. The common difference, which you usually use the symbol d for, well, in sigma notation, this is the common difference. Okay, if you imagine the first term would be 21, the next term would be 4 times 6 plus 1, which is 25. You can see that that 4 is what's being increased by every time. So d is 4. The number of terms in the sequence, well, the number of terms is always equal to the upper limit minus the lower limit, and then plus 1. So 20 minus 5 plus 1, which is 16. The plus 1 comes just so we don't forget to count the starting value as well. Okay, so that's just a bit of assessment of what do you know what all the different parts of sigma notation represent. Now let's look at a different series. We're told that b and c are constant. The sum is 7735. Show that 55b plus c equals 85. Okay, so this time let's write down the sum formula. So the sum of n terms is n over 2 2a plus n minus 1 times d. Let's put in what we know. So 7735 is the value of the sum. The number of terms is going to be 100 minus 10 plus 1. So that's 91. So we know that. The first term is when we substitute r equals 10 in there. So that's 10b plus c is the first term. So 2 times 10b plus c. And then n minus 1, so that's 91 minus 1 is 90. And b, so the common difference d is represented by the value b here. So we'll put that in as well. So we just need to rearrange really to get the equation given. So let's first of all expand inside of that bracket. So 91 over 2 multiplied by, so 2 times 10b is 20b plus another 90, that's 110b, and then 2 times c. Bring the half here, bring that inside. So 110 over 2 is 55, and 2 over 2 is 1. Okay, so just multiplying that through. So all we need, hopefully, oops, sorry, I've missed a b off there, that's disappeared. So hopefully if we divide 7735 by 91, we should get 85. So just confirm that with your calculator, and yeah, it is indeed true. Right, the 40th term of the series is 4 times the second term. So the 40th term in the series, let's write that as u40, is equal to 4 times the second term, u2. Well, we know if it for the 40th term, we're starting with r equals 10, so the value of r for the 40th term is going to be 39 more than that. So it's going to be, r is going to be 39. And in the other case, r is the second term. If the first term is 10, the second term is going to have r is equal to 11 in. So we got 49 times b plus c is equal to 4 times 11 b plus c. Okay, we'll multiply out the right hand side there. And if we rearrange that, then we get 5b minus 3c equals 0. But we also know from the first part of the question, we also know that 55b plus c equals 85. So we just need to solve these simultaneously. What's the easiest way to do that? Maybe if we multiply the second one by 3, then we get 165b plus 3c equals 255. So add that to the first equation, and we get 170b, the c's cancel out, is equal to 255. So b, if we do that on a calculator, we get 3/2. And to find c, we need to substitute that back in somewhere, so I'd probably use this equation. So if we rearrange that equation, we get c is equal to 5b divided by 3. So 3/2 over 3, the 3's cancel, and that's 5/2. Of course, you can just use your calculator to do that quicker if you want. Right. Bit of a trapezium rule next. So we've got this equation, ln of 8 minus x, which is shown here. And first of all, we said use a single trapezium to find an approximate value. So what we're doing is we're just drawing a straight line across there. I mean, that's not a straight line at all. And we're just forming this single trapezium of the whole object. So the area of that trapezium is going to be equal to 1/2 of h. Okay, so this is h, the height of the trapezium, and then a and b, the two ends, 1/2 of a plus b. So what are we going to have? Well, h is going to be 6 minus 1, so that's 5. And then a plus b, well, these are just the values at each end. So at the right hand side, we're going to have the log of 8 minus 6. So I'm just putting the values of x at these two ends back into the function. And for b, I've got ln of 8 minus 1. So 5/2 multiplied by ln2 plus ln7. And I can use my rules of logs to write that as the log of the product of those, so ln14. And if I just go to my calculator, because it's asking me to calculate this to 2 decimal places, this is approximately 6.60 square centimeters. Then they've decided to make some sort of metal shape out of this. So these areas are duplicated 4 times, arranged in a ring, and the metal that's made from has a thickness of 2 millimeters. And we're given the density. And we need to find the mass of this to the nearest gram. Okay, so this time we're going to use a trapezium rule with 6 ordinates. So let's first of all work out the area with this level of precision. So we've got 1/2 of h. Now, if it's 6 ordinates, then each ordinate is just going to have a height of 1. Okay, remember it was 6. That h was 6 before all the way along. So if we split that up into 6 bits, each bit is going to be 1. Multiplied by the 2 endpoints, ln7 plus ln2, plus 2 times all of the other values, which are just going to be ln3, ln4, ln5, and ln6. Okay. You can use your rules of logs to simplify this before you use your calculator. Save yourself a little bit of time. So combine the two outside, ln 14 like we had before, and then all the bits inside. So 3 times 4 is 12, times 5 is 60, times 6 is 360. And if we put that into our calculator, we find that the area of one of these shapes is 7.2056. Okay, which is a bit better than before. So if we want to find the volume of this whole shape, okay, so this was the area of one bit, the volume of the whole shape is equal to 4 times the area of 1, and then multiplied also by the thickness. I'll call that T, the thickness. So we've got 4 times 7.2056, and the thickness is 2 millimeters, but we're working in centimeters, so that's 0.2 of a centimeter. And if we put all that together, we get 5.765 cubic centimeters. And then finally, we want the mass of this. So mass is equal to the density, so that's grams per cubic meter, times by the number of per cubic centimeter, multiplied by the number of cubic centimeters, so multiplied by the volume. So 10.5 times 5.765, and that's approximately 61 grams to the nearest gram. So that's the precision that we were asked for. And without doing any more calculations now, we've got to say, first of all, give a reason why the mass that we just found could be an underestimate. Well, because of the shape of the curve that we've been approximating, all of the trapezia that we split it up into are all lower than the curve. Okay, I mean, we split it up into 6, but we've got that. Okay, so that's an underestimate because we're missing out all of these bits. Okay, so you could say the trapezia are all under the curve. Why is it an overestimate? Well, this is probably a little bit easier to think about if you study any of the other sciences, like physics, for example. It's because everything is just rounded. Okay, so for example, you could add a rounding error in the density. The density was only given to 3 sig figs. There was a rounding error in the thickness. That was only given to one significant figure, just 2 millimeters. And the other distances too. So it could be that there are rounding errors which lead to errors in the final value. Question 12. A curve has this equation and passes through this point. Show that a equals 2. So let's just substitute the values in. So we've got root 3 cubed times sine pi over 6 plus cos pi over 6 is equal to root 3 times a. Root 3 cubed, well, that's root 3 squared times another root 3, so that's 3 root 3. Sine of pi over 6 is a half. Cos of pi over 6 is root 3 over 2. So we get that. The left hand side, I've got 3 over 2 lots of root 3 plus another half of root 3. Oops, sorry, that should be equals. So I've got 2 root 3 is equal to root 3a. So therefore a is 2, as we were asked for. Okay, show that dy by dx is given by this. Okay, well, we're just going to differentiate implicitly. Okay, so implicit differentiation. So the first term is a product. So we're going to have x cubed multiplied by the derivative of sine, which is cosine. But then because we're differentiating with respect to x and not y, we need to multiply by dy by dx, the chain rule. Okay, so this is my u dv. Now I need to do it the other way around, so I need to differentiate the x cubed to get 3x squared and then leave the sine y alone. Okay, and then the next term, cos y, that's going to integrate to minus sine y, and then again multiply by the derivative. And on the right hand side, I've got 2x. Remember, a is 2, so I've just got 2x, so that differentiates to just give 2. Okay, so what we need to do here is just collect all the terms. So I'm going to group together the terms on the left hand side that involve the derivative. So that's x cubed cos y minus sine y. And I'll move the 3x squared term to the other side. And then all I need to do is just divide that bracket across and I get the answer I'm looking for. So actually quite an easy 5 marks there, I would think. Part 2, find the gradient of the curve at P. So we need to substitute in these values now. Remember, x was √3 and y was pi over 6. So we just substitute it into the expression that we just had there. So we get 2 minus 3 √3 squared times sine pi over 6 divided by √3 cubed cos pi over 6 minus sine pi over 6. So let's try and work these bits out. So I've got √3 squared is 3 times 3 is 9, and then sine pi over 6 is a half, so I've got minus 9 halves. √3 cubed is 3 √3 multiplied by √3 over 2, so that's going to give 9 over 2 there, and then sine of pi over 6 is a half. So on the top, 2 is the same as 4 over 2, so I've got minus 5 over 2 on top, and then 9 over 2 minus a half is 8 over 2, which is 4. So I got minus 5 over 8. We're going to need that for the next part because we now need to work out the tangent. So remember, a tangent is just a straight line, and we know that the gradient is minus 5 over 8. And we also know the value of x and y at a point on that curve, so that will allow us to find c. So we know when y is pi over 6 and the gradient we just found is minus 5 over 8, and the value of x is √3, then that gives us that c must be equal to pi over 6 plus 5 over 8 √3. So y is equal to minus 5 over 8x plus pi over 6 plus 5 over 8 √3. And the question is, what's the x coordinate? Well, the x coordinate is where y is equal to 0. So we just need to solve this equal to 0. So we'll move the x term to the left hand side. That will become 5 over 8x is equal to that, and then multiply by 8 over 5. And you can expand that bracket. So in the first one, I've got 8 over 30, which is the same as 4 over 15. So 4 over 15 pi. And then you can see for the second term, the 8s and the 5s cancel, and you just got √3 left over. So the x coordinate is that. Okay, now on a function. So some function is defined like that. And we're told that the domain is all real numbers apart from x equals 2. Find the inverse function. The easiest way to find the inverse function is to write y equals 2x plus 3 over x minus 2, and then rearrange for x, and then switch the labels. So cross multiply first of all, multiply everything out, and then we'll move all the x terms to the left and all the y and all the other terms to the other side. So I've got yx minus 2x is equal to 3 plus 2y. Factorize. And then finally divide. And then because we know that a function and its inverse are a reflection in the line y equals x, if you draw them on a graph, then the final step is to switch labels y with x. So we can write that down. And what you'll notice, I'll just write it slightly differently. I'll just swap the two terms on the top around. You can see that, so this is inverse function of x. You can see that it's actually the same as the original function, which is useful for the next part. So write down an expression for f of x. Well, f of x then, you could, if you hadn't spotted that, you could just substitute this value in place of there and then you'd be done. But if you did spot that, then this is obviously the same as f of the inverse, since they are the same function. Oh, sorry, actually, before I do that, let's just go back to the previous answer. I should also, if I'm writing down the function, I should have written that what the domain of that was as well, of the inverse. Okay, there'll be a mark for that. Okay, so back to this one. So I've got the function, the composition of the function and its inverse. So that's just going to give x back again. Okay, so that's probably the easiest way to do the second part if you spot it. If not, just substitute the function into itself and you'll get an expression anyway. Right, 13b now. Find the range of g. Now, we have to be a little bit careful when we're finding ranges here. So first of all, we've got a domain restriction, 0 to 4. And it's a quadratic. So what we've always got to check with a quadratic is, does the quadratic dip below the endpoints of the domain? Okay, because if it does, then we have to be a little bit careful when we find the range. So first of all, let's find just the value of g at the endpoints. So if I put g is 0 in, I get 0. If I put, sorry, x equals 0, I get 0. If I put x equals 4 in, I get so 2 times 16 minus 5 times 4 over 2. So 32 minus 20 is 12 over 2 is 6. And let's just work out the derivative. So I'm going to use prime notation here. So g primed, so the derivative of this, so 2x squared becomes 4x over 2, so that's 2x. And then minus 5 over 2x differentiates to minus 5 over 2. So that's going to have a turning point when the derivative is 0. So that gives x is equal to 5 over 4. And if we substitute that back into g, then we get y is equal to 2 times 5 over 4 squared minus 5 times 5 over 4 divided by 2. Um, 5 squared is, so I've got 2 times 25 over 16 minus 25 over 4 divided by 2. So that's 50 over 16 minus multiply by 4 there. 100 over 16 divided by 2 minus 50 over 16 over 2, so that's minus 25 over 16. Okay, again, you could just do that with a calculator, probably a little bit quicker than I just did there. So this is actually the lowest point because that's lower than 0 or 6. Okay, so this is the lowest, sorry, well, it's lower than 0. So that means that G actually has a range of 6 being the highest value, but it can actually go down as low as this minimum point. How do we know it's a minimum, by the way? It's because this is a quadratic with a positive a. Okay, so we know it's a minimum. We know it's that shaped curve. So B part 2, determine whether it has an inverse. Well, the curve is going to look like this. So here's our minimum point. So it increases on one side, increases on the other side. Okay, so it goes up to 0 here and up to 6, x equals 6 there. So it has that shape. So for G, two different values of x give the same value of g of x. Okay, so G is a many to one function. Okay, we can see that from the graph, and therefore there's not an inverse. So this test, if you draw a horizontal line on and it crosses through two parts, this is sometimes called the horizontal line test, and it's a quick way to check if it has an inverse or not. Part C, show that this is true. So the composition of G and F. So G was 2x squared, first of all. So we've got 2 times 2x plus 3 over x minus 2. That was F. Minus 5, lots of that. And then divided by 2. So if we multiply top and bottom by x minus 2 squared, then we're going to get 2x minus 2 squared on the bottom, and the top is going to simplify to 2 times 2x plus 3 squared minus 5 times 2x plus 3 times x minus 2. So multiply all of this out. Well, let's do the brackets first. So 2 times 4x squared plus 12x plus 9 minus 5 times 2x squared minus x minus 6. And on the bottom, 2x squared minus 4x plus 4. And then all that remains to do is just to multiply that out and collect the terms together to get the value up here. So hopefully you should be able to do that bit yourself. And then last bit here is that if we've got f of g of x, so the other way of composing those functions, we're told that the domain is x between 0 and 4, but not equal to a. So there must be an asymptote at that point. So what we really just need to do here is just to look at the denominator and say where is that equal to 0, and it doesn't factorize, so we'll just use the quadratic formula. So we've got minus b, that's minus 5, plus or minus the square root of b squared minus 4 times a times c. So that's going to give plus, so 4 times 2 is 32. And then divided by 2a, so divided by 4. So we get 5 plus or minus root 57 divided by 4. Well, root 57, that's going to be 7 and a bit. Okay, so root 49 is 7, root 64 is 8. So it's a bit more than 7. So 5 minus that is going to be a negative number, but that's not in the domain. Okay, so only x is equal to 5 plus root 57 over 4. Okay, and you should just double check that that is in the domain, but that is the value. We'll just leave it like that because we're not asked to simplify that, express it approximately. Question 14, nearly there. So this is like what we had right at the start, a change of sign. So f of x equals 0 has a single solution at the point x equals alpha. By considering a suitable change of sign, show that alpha is between 0 and 1. So what we do is we just put those values 0 and 1 into the function and check that the sign changes. So f of 0, so that's going to be 3 to the power of 0 times 0 minus 1, so that's minus 1. And if I put 1 in, I get 3 to the power of 1 times 1 minus 1, that's 2. So change of sign, therefore alpha must be between 1 and 0. Then the derivative f primed. So we've got to use the product rule for the first term there. So 3 to the x, the derivative of a to the x is ln of a multiplied by a to the x. So the derivative of 3x is going to be ln 3 times 3 to the x, and then leaving the square root of x alone. So we're using the product rule again. And then we're going to leave the 3 to the power of x bit alone and differentiate the root x. So that's x to the half, so that becomes a half x to the minus a half when we differentiate it. And then differentiate minus 1, that just gives 0. So we need to tidy that up a bit to get the answer given. So let's put everything over 2 root x like we want. So the second term, we've just got 3 to the power of x left over on the top. In the other term, if I'm putting 2 root x on the bottom, I need to multiply the top by 2 root x. So I'm going to have 2 ln 3 times 3x, and then root x times root x gives another x. So I get that. So take out a factor of 3x. So I get 2 ln 3, I'll put the x in front, x2 ln 3 plus 1 over 2 root x. And then finally, the last step is just to bring the coefficient 2 inside as a power into that logarithm. So I'm going to get 3x, x times ln of 9, 3 squared is 9, plus 1 over 2 root x, which is what we asked for. Not really bothered about swapping the order of those terms around. Newton-Raphson method. So let's just write down the Newton-Raphson formula because we're going to use that. So the n plus 1th value of x is equal to the nth value minus the ratio of the function at xn divided by the derivative at xn. So in this case, using what we've already calculated, we've got minus 3 to the power of x root, so xn, root xn minus 1 divided by, and this was the derivative that we just calculated, so 3 to the power of xn, 1 plus xn times ln 9, and then divided by 2 root x. So if we divide by and then divide again, that's going to be multiplying on top. So we'll put that up there. Now, the easiest way to do this on your calculator is to type in the first value, x1, and then press equals. And that will store it usually in your calculator in something maybe like answer. There'll be an answer button on most calculators now. And then what you should do is you should type all of this into your calculator, this whole expression, and everywhere there's an xn, just instead of you would just press the answer key instead. So you'd had something on your calculator like ans minus bracket 3 to the power of ans, and so on. Okay, so that whole expression like that. And then all you have to do is just press equals a couple of times and you'll get the other values. So you'll find x2 is about 0.58297 x3 is 0.424653 and so on. And that's the one that we're looking for, x3, and we want it to 5 decimal places. Okay, so look at the 6th decimal place, it's less than 5, so that means that the third approximation is 0.42465 to 5 decimal places. Why does Newton-Raphson method fail if we use x1 equal to 0? And the reason that is that it's impossible to converge. The Newton-Raphson method relies on taking a function and taking a tangent back down to the axis and then using that as your next value. What we've got here, if we put x equals 0 into the derivative, we find that that's undefined. Okay, it becomes infinite because the 2 root x that was on the bottom, that would be 2 root 0, 0. We'd be dividing by 0, so that's undefined. And what that means in terms of the gradient of that line is that that tangent line is vertical. So what it means is that your original value, whatever the shape of the graph is, you're going up there and your tangent is also vertical, so that takes you straight back down to the same point. Okay, it doesn't get you closer to the solution, it just takes you straight back down. So if you start at 0, then every other value of n will still be 0 because it'll just keep taking you down to the same point again and again and again. Okay, but that's probably enough to say that it's impossible to converge because the tangent is vertical. Right, last question. Almost there. So it's a one about area between curves, and it's a big 10-mark question just to finish off the paper. What's the area between these two curves? Well, the area between two curves can be written like this. It's the upper curve minus the lower curve. Okay, between 2 points A and B. So here, the upper curve, this one here, this is the 6 minus e to the x over 2, and then subtract the lower curve, which is just e to the x. So that bit's easy, and we can see from the diagram we're integrating from 0. In fact, we're told that in the question as well. But we need to find this other point here, this intersection point. So we need to equate the two lines. So let's do that over here. So e to the x is equal to 6 minus e to the x over 2. Let's move everything to the same side of the equation. And this is actually a quadratic. So if you choose y is equal to e to the x over 2, then y squared is e to the x over 2 squared. In power to a power, we multiply the powers, so that's just e to the x. So we can rewrite that as just y squared plus y minus 6 is 0, which factorizes quite nicely. So this is y plus 3, y minus 2. And that has a solution y equals 2, which is e to the x over 2 equals 2. I'm not going to have equal to minus 3 because the exponential can't be equal to minus 3. The exponential always has positive values. Okay, it's non-zero and non-negative. So it's always positive. Just solve this. So take logs of both sides. So x over 2 is equal to ln 2. So x is equal to 2 ln 2, which is the same as writing ln 4. Actually, both of these forms are useful to us. Let's just put ln 4 though as the upper limit on that integral. So now all we've got to do is integrate and put those limits in, and we have finished the paper. So here goes. 6 integrates to 6x. e to the x over 2, we use the reverse chain rule. So exponential just integrates to itself, but then we have to divide by the derivative of the inner function. So divide by a half, which is the same as multiplying by 2. And then the last term is just e to the x from 0 to ln 4. So let's put the upper limit in first. So 6 ln 4 minus 2. So ln 4, remember, is the same as 2 ln 2. So we can write this as e to the ln 2. And then minus e ln 4. And if we substitute in the lower limit, we just get 0, minus 2, minus 1. So 6 ln 4. e to the ln 2, well, exponential and logarithms are the inverse functions of each other. So e ln 2 is the same as just 2. So I've got minus 2 times 2. Then by the same argument, I've just got 4. And then I've got minus, and then the second bracket just gives minus 3. So I've got 6 ln 4 minus 8 minus minus 3. 6 ln 4 minus 5. And there we are. Just what we wanted. Finish the paper. Whew! So I really do hope you've found that useful. You may have even enjoyed it. If you do, please like the video and subscribe. And if you want any additional support, okay, then please visit my website because I offer tuition for maths and physics, okay, or other subjects. So please get in touch if you've got any tuition needs. Okay, bye for now, everybody.